Hey guys, welcome back to my channel and I hope you are all doing great. This is lecture 5 on linked list series. So far I covered 4 lectures starting from introduction to linked list till last lecture we solved a important problem, and in this lecture we are going to solve one more problem which is most frequently asked in FANG interviews also. Without further delay, let's get started with today's lecture. So this lecture is all about like we need to detect if linked list has a loop. If it has a loop, then we need to remove it. So let's see what does mean by it. So we have a list with 1, 3, 4. Okay. So we are given next to, that means the second position node, okay, can be connected with the last node. So 4 is going to connect with the 3. That means there is a loop, right? So we need to remove it successfully. Okay. Let's see, this is a problem from Geeks for Geeks. So the difficulty is medium, and this is one of the part in their curated SDA sheet. So I hope this is going to be a wonderful learning experience for you. Let's see how we can solve this problem. Here is my board. Okay. So assume we have a linked list like this: 1, 2, 3, 4, 5, and 5 is again connecting with 3. If we carefully observe this list, so it has a loop. So our main goal is, instead of connecting this 5 to the 3, instead of forming this loop, it should connect to the null. That is all we need to do. So that we can tell this list does not have any loop at the end. Okay. How we can solve this problem? So as I said so many times, so every problem can be solved in multiple ways. So depending upon how a person is thinking. Okay. So these are the approaches which are in my mind. Okay. Here we can solve this problem using hash map. One thing, hash map. So assume I have a hash map like this, which is going to hold my nodes. Okay, complete nodes, not node value. And I am starting with first node. Okay, here is my head initially. I'm denoting which head. So what I'm going to do, every time I'm going to check whether my head dot next, that is nothing but here too, is already present in my hash map or not. If it is already present, that means it is already visited. Okay, and I'm again trying to visit. Then I mark my current node dot next is equals to null. Okay, let's try to debug this. So here let's assume this as a current. So it's better to have a new reference instead of touching the head every time. So is my current next to is present in my hash map? No. Then you can insert 1 here. Then move current by 1 position. Is my current next, that is nothing but 3, exist in my hash map? No. Then you can insert 2 here. Then you can go further. Is my current next is present in hash map? No. Then you can insert 3 here. Then you can go further. Is my current next is present in my hash map? No. Then you can insert current here. Then go back, go forward. Is my current next? That is nothing but 3. Present in my hash map? Yes, it is present. That means my current is trying to connect to a node which is already visited, right? So simply do current node next is equals to null. That's all. You are done with this solution. So what is the time and space complexities? The time complexity is going to be big O of n because you are going to iterate through the list, and a big O of 1 to perform the contains operation. Okay, so total it is going to be big O of n. The space complexity is going to be big O of n because you are taking a hash map to store your nodes, right? So where n is a number of nodes in the list. So here there is some drawback with the space complexity. So can we do in bit optimized way? Yes, we have one more solution, but let's try to code this. Here what I'm going to do is map node integer. Here I'm taking as a value because I'm going to assume my occurrences. Okay, map is equals to hash map. Okay, node node is equals to head, while node not equal to null. Till that position, okay, I need to move forward in the mean. So I need to check if my map dot contains key of my node dot next. If that is the case, then node dot next is going to be what? Null. Then just do return. Come out of that. Or else you can have the break also. Else map dot put off node comma 1. Okay. 1 is nothing but the occurrence of the node. So before going forward, just increment the pointer. I mean node is equals to node dot next. That's all. Let's run it. Hash map syntax. Yeah, here new. Yeah, it got compiled. Let's submit. Yep, it got submitted successfully and it got passed all the test cases. So this is approach number one. So can we do in much better way? As I said, yes, we can do. Let's see the second approach. So the second approach is too simple. Okay. The first step is we need to detect. Okay, detect if there is a loop or else not. Detect if there is a loop or not. Okay, once you detect the loop, okay, find the node from which loop is starting. Find the node from which loop is starting. And third is remove the loop. Remove the loop. So let's try to understand this. Assume here is how our list looks like. 1, 2, 3, 4, and then 5. 5's next is going to be 3. Then I'm going to use this Floyd's detect cycle algorithm. That is nothing but two pointers approach. Two pointers approach. Okay. I'm going to have slow and fast pointers. And you can see my previous lecture where also I used this algorithm. So you can better understand there. So slow and fast. Okay. So every time my fast is going to run with a 2x speed, whereas my slow is going to run with x speed. The first step is we need to detect whether there is a loop or it's not. So how you are going to detect? So if my fast is equals to slow, that means there is a loop, right? In the process of running with the 2x and x speed. Let's try to understand here. So initially, is my fast null or its next is null? No. Then I'm going to move my fast by two positions and my slow by one position. Then I can check here. Are they equal? No. Then is my fast null and its next is null? No. Then I can move my fast by two positions, then my slow by one position. Are they equal? No. Then is my fast null and its next is null? No. Then my fast is going to point here and my slow is going to point here. Are they equal? Yes. When they are equal, then we need to break the loop there and then. And we are done with first step. First step. We detected the loop. Now we need to find the node from which the loop is getting started. For that, what you need to do here is, so once you able to find whether it has a loop or it's not, then move one pointer to head because it will help us to find the starting of the loop node. Okay, so I'm moving my slow to here. Okay, now what I'm going to do here is while slow not equal to fast, okay, while slow not equal to fast, till this condition satisfies, I'm going to move my fast by one position, my slow by one position, so that I can able to find the starting of the loop node. Let's try to debug that also here. So my slow is, let me take different color pen. My slow is pointing to head, that is nothing but node 1. My fast is pointing to F. Okay, then what I am going to do here is, are they equal? No. Then I'm going to move my fast by one position, my slow by one position. Are they equal? No. Then I'm going to move by one position and I'm going to move by slow by one position. Are they equal? Yes. And you can see this is the node where the loop is starting, right? And we are done with the first step. Now the final step is removing the loop. So how you are going to remove the loop? So the simple condition is while slow not equal to fast dot next. Let me tell you why this condition. So here you can see slow is at 3 and fast is at 3. So in order to remove the loop, you need to find a node whose next should not be the slow, right? So that's the reason this condition. Let's try to understand this case also. Okay. Slow here, fast here. Is my fast next is equal to slow? My fast next is 4, right? Is equal to 3? No. Then I'm going to move my fast by one position. Then is my fast next? That is nothing but 5 is equal to 3? No. Then I'm going to move my fast by one position. Then is my fast next is equal to slow? Yes. 5's next is 3, that is equal to slow. That means this is the node which again connecting to my slow, that is where the loop is forming. So then simply do fast dot next is equals to null so that this link is getting broken. So that's all this problem and this solution. Okay, I hope you understood the approach. Let's try to understand the time and space complexity. So the time complexity is going to be big O of n. The space complexity is going to be big O of 1 because we are not taking any additional hash map or else any additional data structure to process the request. Okay, I hope you understood the approach. Let's get into the coding. The first is, let's, okay, here, if head equal to null or head dot next is equal to null, then just simply do a return. Otherwise, take two pointers as I said, slow is equals to head, node fast equal to head. Okay. Now what you are going to do here is while fast not equal to null and fast dot next not equal to null till this condition satisfies. Okay. Move slow by one position, slow dot next. Move fast by two positions. Fast dot next dot next. Okay. Once you move those two, just check whether they are equal or it's not. If slow equal to fast, then simply break the loop and come out of the loop. And at this position, you can able to find like whether you can able to detect like whether list has a loop or it's not. Then, so what if there is no scope of a loop? Then you need to check if fast is equal to null or fast dot next is equal to null, then you are not going to do nothing there because it does not have a loop. Then how you can remove it, right? And what is the next case? We need to find the starting node of the loop, right? Then for that, I'm moving my slow to the head again. Okay. Then while while slow not equal to fast till this condition satisfies, then what I said, move slow by one position, slow equal to slow dot next, and fast equal to fast dot next. Okay, you are done with that. Now you are at the position where you are slow and fast pointing to the starting node of the loop, right? Now what I said, you need to check whether slow not equal to fast dot next to detect which node is connecting back to the slow. For that, while slow not equal to fast dot next till this condition satisfies, what you need to do? Just move forward only the fast pointer. Once you can able to understand like my slow is equal to the fast dot next, that means my fast pointer again connecting fast node is again connecting to the slow. Instead of connecting to the slow, just connect to the null. That's all. That's all. So let's compile and run. Compilation error. Yeah, there should not be a spaces somewhere. Yeah, here. Okay, it got compiled. Let's submit it. Yes, it got solved. So that's all for this problem. And one thing you have to remember, this problem is a part of Geeks for Geeks curated SDA sheet. So this is one of the important problem and it's medium also. So I highly recommend to watch this video carefully and try to understand the approach which I said. Thanks a lot. Bye bye.